Namaste students, welcome to PAATHSHALA Pandit. I am Ayus Bhattacharya. Today we will see about valency. So let us write the topic first. Valency. Okay, now see, what is valency exactly? Till now we know that water, elements, water, electrons, protons. You also know that a specific element has a specified number of electrons. Like hydrogen, it will have only one electron. Helium, it will have only 2 electrons. Okay, like this. Lithium, 3 electrons. Like this it will go on. So we know that. Now the thing is, means each element wants its atom to complete its octet. Okay, it wants its electrons to have 8 number of electrons. I will show you. Like see, you know sodium. Let's write its means the number of electrons it has and also the electronic configuration. Okay, so sodium, this is Na, and it is of 11 electrons. Okay, it is of 11 electrons. All right, you know this is sodium, right? Okay, now its configuration means in the first orbit it will have 2 electrons, in the second orbit it will have 8 electrons, and the remaining number of electrons will be in third orbit. Okay, 2 8 1, this is its electronic configuration. So let me draw it also. See, this is the you may say the nucleus. Okay, this is the nucleus. All right, this is the first orbit, this is the second orbit, this is the third orbit. All right, 3 orbits are drawn. Now let's draw of chlorine. Okay, chlorine. What is chlorine actually? It has 17 electrons. Okay, it has 17 electrons, and its electronic configuration will be 2 8 and 7. Okay, done. Let's draw its the atom also. Let me do one thing. Let me draw this with a red marker. Chlorine, this is 17 electrons, 2 8 and 7. Now let's draw it. This is the nucleus, this is the first orbit, this is the second orbit, this is the third orbit. Okay, this is the third orbit. Now let's draw the electrons. We drew the the orbits. Now let's draw the electrons. 2 8 1, 2 electrons, 1 2 3 4 5 6 7 8. Okay, second orbit for 8 electrons, 1 electron in the last orbit, means the third orbit. Done. We drew it. Let's draw in chlorine also. 2 electrons in the first orbit, 8 electrons in the second orbit, 1 2 3 4 5 6 7 8. Done. 8 electrons done. Now 7 electrons in the last orbit, 1 2 3 4 5 6 7. Okay, 7 electrons in the last orbit. Now what happens is, sodium will try to make its this last orbit, or means the last orbit of the this sodium should be 8. It will do it anyhow. Now sodium has 2 options. One option is that to complete its octet, means it should have the last orbit has 8 electrons. So the option 1 is sodium takes, wait a minute, sodium takes 7 electrons. Sodium should take 7 electrons from others. Means if you take 7 electrons, then it will become 288, right? It has this one option. So if he wants to take 7 electrons, then chlorine will have to give 7 electrons. Chlorine gives 7 electrons. Means someone has to give electrons, right? To receive electrons, someone has to give electrons. So chlorine is ready to give 7 electrons. Or we have another option. We have another option. The second option is sodium gives 1 electron. Now see, if sodium is ready to give this 1 electron away, then this becomes 0. This becomes 0. Then it becomes somewhat invalid. If sodium gives away 1 electron, then it becomes this 2 and 8. But the condition is satisfied, right? The last orbit should have 8 electrons. The condition is satisfied. So sodium will see that the second option is also available, that I will give away my 1 electron. Okay. The second option is also there, gives 1 electron. And another option is, means the second step is chlorine gives, sorry, not gives, actually it takes. Chlorine takes 1 electron. Alright, chlorine takes 1 electron. So what will happen, that 7 will become 8, correct? 2, 8, 7, and if it takes 1 electron from here, means if sodium wants to give out 1 electron, there must be someone to take it also. Otherwise sodium cannot give it to just in the air. No, it cannot happen. So chlorine is ready to take 1 electron. And we can see that if it takes 1 electron, it will become 288. Means the last orbit is having 8 electrons. So now we have two options. What will happen, means what is convenient to use according to you? Taking and giving 7 electrons or taking and giving just 1 electron? Here you have to move 7 electrons like this. Someone is giving, someone is taking 7 electrons. The movement is too much. But here in option 2, there is only 1 electron to be moved from here to here. So what do you think will the atoms choose for their convenience? Correct. Option 2 will be chosen because it is more convenient to just move 1 electron instead of 7 electrons. Alright. So this is what is known as valency. The proper sentence I will give you. The capacity of an element to combine is called its valency. Okay, I will write it also, but still I will reciting it or dictating it. The number of electrons that an atom of an element gives away or takes up while forming an ionic bond is called the valency of that element. Okay. Now see what happens is, if you take, means if it is ready to give out 1 electron and it is ready to take 1 electron, then a bond happens. What happens is a bond. Na plus okay. Now see here, if it gives away 1 electron, then this third orbit is useless. Okay, third orbit is useless, so do not draw it. Done. There's 2 orbits, 1, 2. Let me draw the nucleus bigger. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So okay, Na plus. Now why I am writing as Na plus? Because Electrons are negative, protons are positive. If you remove one electron, what does that mean? It means that you remove some of the negativity out of yourself. Some of the negative energy is removed when an electron is removed. So if the positive and negative is balanced and you remove an electron, means you remove some negativity, what it will become? It will become positive. It will become positive. Now suppose I remove another electron, then it will become more positive. Remove another electron, it will become more positive. Okay, that is what happens. So here we remove one electron. Since it is just one, we wrote only plus. Okay, we wrote only plus. Now chlorine, it took one electron, means it was first neutral, then it took more negativity from the electron, means the electron that is coming from outside, it entered into chlorine and it became negative. You understood the logic, right? Okay, so let's draw the chlorine also. Now see what happens here is 2, 8. Okay, 2, 8. Let us draw chlorine. Cl minus, it is 2, 8 and 8. It takes one electron, so it becomes 8. Now let me draw this also. 1, 2, 3. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8. Second orbit done. Now the third orbit. 1, 2, 3, 4, 5, 6, 7, 8. Like this, the octet is complete. The condition to fulfill that means the last orbit should be complete 8. Should be complete. It is complete. So now Na plus and Cl minus comes together and forms one compound, which we say as NaCl. NaCl. Remember, the positive one will come first, the negative one will come afterwards. NaCl. And what is NaCl? You know the salt you eat means you put in your food or whatever, table salt, that is known as NaCl. Salt. Alright. So this is how means you may say that an understanding happens between atoms. Okay, and in proper scientific terms it is known as a bond. It is known as a bond. Now there are many types of bond. There are covalent bond, there are coordinate bonds, like this. There are many bonds. This bond is known as an ionic bond. This bond is known as ionic bond. Now what is ions? See, what are ions? I am telling you. Ions are those things which are not neutral. Means Na, it was first neutral, equal number of protons, equal number of electrons, so it was neutral. But after giving out one electron, it become Na plus. Okay, it becomes Na plus. Chlorine, it was first neutral, positive and negative, they are both balanced. But then it takes one electron, so that it has to satisfy its octet, and then it becomes Cl minus. So these things which are not neutral, they are known as ions. So if something like this happens, that the atoms are ready to give out or take some negativity or some electrons, then such kind of a means you may say understanding, such kind of an understanding is known as ionic bond. Alright, this is known as ionic bond. So this is what is called valency. Now I am writing the proper definition, then you will completely understand what is actually happening. Okay, so let me first erase it. तो अब valency का एक proper definition देख लेते हैं. The number of electrons that an atom of an element gives away or takes up जैसे कि मैंने उस NaCl के केस में बताया था, ये है Na+ जो कि है 2 8, और जो एक मिनट, यहाँ पे पहले क्या था, पहले था 2 8 1 और वो बन गया Na+ जो कि है 2 8। एंड क्लोरीन का भी जो है वो देख लेते हैं। क्लोरीन पहले था 2 8 7, वहाँ से बन गया क्लोरीन -2 8 8। तो जितना उसका कैपेसिटी है, मतलब जितना वो इलेक्ट्रॉन्स दे पा रहा है या ले पा रहा है, जैसे लाइक आई एम सॉरी, मैं हिंदी में बात कर रहा हूँ, इंग्लिश में बात करते हैं। सो सी 281, the number of electrons that an atom of an element gives away or takes up means 1. If it is given out just 1 electron, then that means the sodium has valency 1. Its valency is 1 because it gives only 1 electron. It cannot give out more electrons. Next, what is valency of chlorine? Chlorine also you can see it can take only 1 electron. After that it is full. Then chlorine has valency 1. Alright, chlorine has valency 1. So while forming an ionic bond, after becoming Na+ and Cl-, they become NaCl, which is sodium chloride. Now what is NaCl? It is an ionic bond. It is an ionic bond, which is why it is mentioned here. While forming an ionic bond, if it gives out or takes the number of electrons, that is known as the valency. So understood? Na+, Cl-. Let's take one more example, then it will be perfectly clear to you. Magnesium. Okay, magnesium, it has the electronic configuration is, just a minute. Okay, its electronic configuration is 2 8 12. Oh, sorry, not 12, 2 8 2. Okay, its electronic configuration is 2 8 2, and it can give out 2 electrons. Okay, magnesium, it has 2 electrons. It can give out 2 electrons out so as to become 2, 8. Okay, so what does that mean? It will give out 2 electrons, which means it will remove 2 negativities, means it will become 2 times positive. It will, here it was 1 plus, here it will become 2 plus. Next, what is happening? Let's take the example of chlorine only. Chlorine, it is 2 8 7, it becomes Cl-, which is 2 8 8. Now it is giving out 2 electrons. Magnesium is giving out 2 electrons, but chlorine is, one chlorine atom takes only 1 electron. So if one magnesium gives out 2 electrons and one chlorine takes 1 electron, how many chlorine atoms are needed to take 2 electrons? Of course, it will be 2 chlorine atoms. So what is happening is the compound that forms is MgCl2. There are 2 chlorine atoms which are taking 2 electrons from magnesium, and only one magnesium atom that gives out 2 electrons. So what is the valency of magnesium then? The magnesium valency is 2. Magnesium valency becomes 2 because it gives away 2 electrons while forming an ionic bond. This is also an ionic bond, MgCl2, just like NaCl. Let me write here NaCl. Similarly, I can give you another example of let me give you the example of boron. Okay, boron. What happens with boron is, yes, boron. Where can I show you the example of boron? Let me show it here. Boron. Boron has the electronic configuration of 2 and then 3. Yes. Okay, 2 and 3. Now see, what will happen? What is happening is, here it cannot perform an octet condition. Okay, here it cannot perform an octet condition. Or wait, let me do one thing. This example is a bit complicated. Let me give you the example of aluminium. Okay, let me give the example of aluminium. Al, it is 2. Let me count the number of electrons it has. Well, okay, it has 13 electrons in total. So 2, 8 and 3. Okay, 2, 8, 3. Now it can give away 3 electrons. Okay, it can give away 3 electrons to become Al3 plus. It can, so that it becomes octet. Forget about that boron example for now. It is a bit complicated. If it happens that the syllabus comes in the class 9 textbook, then I will of course teach it, don't worry. But for now, remember this octet condition. Now remember, what is this called? This is known as octet. Just a minute. Octet rule. This is known as octet rule, where it has to become 8. The last orbit has to become 8 in electrons. So see, now what will be the valency of aluminium? Correct, it will be valency 3. It will be valency 3. Okay, so till now you understood what is happening. And another thing to remember, the valence, this is valency. Okay, this is valency, means how many electrons can give or take. But you must also know what is valence electrons. What are valence electrons? Like in the case of sodium, okay, here 2 electrons, here 8 electrons are there, but in the last orbit it has 1 electron. It has 1 electron. Then that means that its valence electron is 1. There are only 1, means there is only 1 valence electron in sodium. Let's see the case of chlorine, and then you, means first let me draw it, then you will tell yourself what is the valence electrons, mean the number of valence electrons in chlorine. Okay, let me draw it. See, it has 7 electrons in the outermost orbit. Now tell me the number of electrons, I mean the number of valence electrons in chlorine. Correct, the number of valence electrons in chlorine is 7, because in the outermost orbit there are 7 electrons. That simple it is. What are the number of valence electrons? The number of electrons in the outermost orbit. What is valency? The number of electrons can it give and take. Simple. Okay. So these two concepts you understood till now. Now another thing you must remember is that what are cations and what are anions. Let me do one thing. Let me erase out this board, then we will see what are cations and anions. Okay, let's see what are cations and anions. Okay, cations and anions. So cations means the ions which are positive. Okay, cations are the ions which are positive. Wait a minute. Positive ions. So Na plus, it is positive. Mg2 plus, it is positive. Al3 plus, it is also positive. Like this, which are positive, here the sign will be positive, those are cations. Means they have given away electrons. Those are the cations. What are anions? Of course, you have guessed it right. Negative ions, like Cl minus, like Br minus, oxygen 2 minus, then nitrogen 3 minus, like this. There are many more such cations and anions. Now remember one thing, sometimes people get confused, what are cations, what are anions? Is cations the negative ions or is anion the positive ions? Like this, they sometimes get confused. So remember, what I am saying means what I am doing right now is not scientific. Okay, it is not scientific, but it is a good way to remember what means to remember if anion is negative or if anion is positive, like this. An ion. Okay, you can see it, anion. I have wrote anion here. So this is A, this is negative, this is ion. The full form of anion, you must consider it as a negative ion, like this. This is completely unscientific, alright? The completely unscientific, but a way to remember how means what is anion, a negative ion. So like that, you can automatically remember that cation should be positive. If anion is a negative ion, then cation should be positive ion. Okay, this is understood. Now, what other names do these have? One name is cation, another name is basic radicals. Let me do one thing. Let me write this here itself. Cations are also known as basic radicals. Basic radicals. Okay. Now, why are they called basic radicals? I will explain in higher classes. For now, just remember they are known as basic radicals, and these anions are known as acidic radicals. Acidic radicals. Okay, remember one thing, these cations, these sodium, magnesium, aluminium, all these things, they are basic, which means that whenever they form a compound, which they will give out blue litmus paper, they are known as basic radicals. I will tell you how it happens, but for now remember, when they form a compound and if it is tested in litmus paper, you know litmus paper, the small papers, you know that. If you dip that litmus paper in this compound, you will find out the litmus paper has turned blue. Okay, so that is the the property of basic radicals, and you should remember it also in this color itself. Whenever you think what are basic radicals, you must think it in blue color. It will be helpful for you. If you think it in any other color, you might forget if it is basic radical or not. But if you remember clearly that Na, it is means I have written it in blue, and you will also remember it blue, then you will means in a split second you will get to know, yes, it is basic radical only, it is cation only, it is positive ion only. Alright. Similarly, acidic radicals, if any compounds are formed from that and you dip the litmus paper there, then it turns red, it turns out red. Like that you have to remember, I suggest you to remember these ions in red color itself, so that whenever you recall, you immediately know that it is acidic radical or it is an anion, like this. So okay, basic and acidic you got to know. Now one more thing is the variable valency. Okay, variable valency. Now see, before I teach you variable valency, I must teach you how to pronounce the compound name. Okay, C, Na, and this is of Cl. Okay, what is the valency of this Na? It is 1. What is the valency of Cl? It is 1. What you will have to do is that take this one here, take this one here, and the end result will be Na1 and Cl1. Okay, or generally if it is 1, then it is not written as 1, it is just written NaCl. Okay, next example is of Mg and Cl. Mg valency 2. Remember, these are valencies. Okay, valency. Cl is 1, cross, therefore it will become Mg1 Cl2, or it will be MgCl2, like this. Another example, sodium, and this is sulfate. Okay, now see, it is not at all necessary that only this one element will be a radical or it will be a cation. No, it is not at all necessary. Sometimes due to some special conditions, things like this, like sulfur is also there, also 4 oxygen atoms are also there. Some special conditions happen due to which they together form or act like a ion, like an ion. It can be a cation also, it can be an anion also. In this case, it is an anion. It is of negative charge. And remember, I told you before itself, positive should be written first, the negative one should be written afterwards. Like this is positive, this is negative, this is positive, this is negative. Let us see it here also. This is sodium 1, this is sulfate, which is 2. Okay, cross it. Crossed, it becomes this is valency again, it becomes Na2SO4. Okay, Na2SO4. And let me take one last example. Last example should be of what should I take? Yes, aluminium and sulfate. Aluminium and sulfate. Valency of aluminium is what I told you just now, it is 3. What is of sulfate? It is of 2. What will happen? Cross it. It will become aluminium 2 SO4. Now see how I am writing it. SO4 is there. Put brackets around it. Put brackets. Then write 3. If you see that there are more than 1 atoms in an ion, if there are more than 1 atoms in an ion, then if you have to put a number beside it, you have to apply brackets to it. Here there was only 1 atom. There was, for the sodium ion, there is only 1 atom which is of sodium, but here it is a sulfate ion. I am telling it now, it is known as a sulfate ion. In sulfate ion, there is 1 sulfur and 4 oxygen, means more than 1 atom is there. Therefore, you have to apply brackets and then write the number. Okay, understood? Very good. So this is how the names are written out. Now how to pronounce it? I will provide you a chart of the names of the ions, but still in here I will show you. This is known as sodium, this is known as chloride. sodium chloride. This is magnesium chloride. This is sodium sulfate. This is aluminium sulfate. Okay, like this it is pronounced. I will give you a chart like that, you can easily pronounce any compound. Okay. Okay, now the last topic is variable valency. Let me rub out this board, then we will see about it. Okay. Now let's see variable valency. Variable valency. Okay. Now what is variable valency? It means that sometimes the atoms which are there, they don't show only one type of valency. Like the case of copper. Okay, copper, its symbol is Cu. Now according to different conditions, okay, according to different conditions, sometimes it shows, sometimes it gives out only one electron, sometimes it gives out two electrons. Okay, 1 and 2 means yes, that is what happens. Means it, just remember for now that it is upon the condition that it gives out electrons. It also depends on the octet condition, I told, but it also depends on other conditions too to give out the number of electrons. So sometimes when it gives out one electron, it will become Cu plus. Sometimes when it gives out two electrons, sometimes when it gives out two electrons, it will become Cu2 plus. Now this is known as cuprous. This is known as cupric. Okay, done. Next is copper, then copper, another example, mercury. Mercury, it is Hg. Sometimes it gives out one electron, which becomes it will become mercurous, is it? Yes, mercurous. Sometimes if it gives out one electron, then we will call it mercurous. If it gives out two electrons, it will be named as mercuric. Copper, mercury, iron. Okay, iron. Sometimes iron gives out two electrons. Okay, sometimes iron gives out two electrons. Then it will become ferrous, isn't it? Yes, ferrous. Remember, it is a different name. Do not name it as ironous. Okay, don't do that. It is known as ferrous. Or if it gives out three electrons, okay, it gives out three electrons or sometimes two electrons, then in 3 electron case it will become ferric. Okay, so what happens is sometimes it becomes FeCl2 if it is 2. Here if it becomes FeCl2, or if it is ready to give out 3 electrons, it becomes FeCl3. Means if it forms a compound with chlorine, it will form FeCl3. So different conditions, different compounds like this. So how to remember the names? One simple technique, I think you have guessed it by now, is that if it is the electrons that are the atoms which are variable in valency, they have I think two options. In most cases they have just two options, either 1 or 2, or either 2 or 3, or either 1 or 4, means any two options. They can choose any two numbers between 1 and 4. Okay, so copper has chosen two options, either it can give 1 electron or it can give 2 electrons. So the lower one would be named as Os. The lower one is Os. The higher one is Ric or Ik, whatever it is. The lower one is Os, higher one is Ik. Here also it is one. It chose two options, 1 and 2. The 1 is lower than 2, so it is named as Os. 2 is higher, it is known as Ik. Iron, 2 or 3. Okay, here it does not mean that always if it is 1 only, then it will be Os. No, the lower one will be Os. So mercury means here it chose two options, 2 or 3. So it will be either ferrous or it is ferric. Okay, like this it happens. Now let's see how to calculate the valencies. It's not the variable ones, the fixed ones. Okay, let's see. Now let me do one thing. Okay, let me show it here itself. See, what is the number of electrons, then the configuration, electronic configuration, then comes what comes, it is valence electrons, then the valency. Okay, then the valency. Okay, and these are the elements. Okay, so let's see one by one. Element is hydrogen, then the number of electrons it has is 1. Hydrogen, it has only 1 electron. What will be the configuration? It will be 1 only. Okay, it will be 1 only. Then or don't write the bracket, it will be 1, just remember it, it will be 1. What are the number of valence electrons? Mean the number of electrons in the outermost shell, outermost orbit, it is 1, of course. So what will be the valency? It will be 1. What will be the number of, means what will be the valency? Remember, in the first shell it can accommodate only 2 electrons, so the valency, it will be 1. Then comes the helium. Okay, helium has number of electrons 2, the configuration is also 2, means the first orbit, it is of 2 electrons. The number of valence electrons, what are the number of valence electrons? It is 2. The number of outermost orbit, the number of electrons in outermost orbit, it is 2. What is the valency then? Valency is 0. Why? Because it is complete. It is complete in itself. It has got 2 electrons. I mean this is the exception I was talking about while writing the boron part. What happens is, in hydrogen, helium, or some means elements closer to this, the this atom is there, the nucleus, then the outermost means the first orbit. Here there cannot be 8 electrons possible. Here 8 electrons cannot be fit. So the condition is fit only 2 electrons. Okay, here the condition is to fit just 2 electrons. Then it will be satisfied and it will be happy. Basically it will be happy. So in hydrogen there was only 1 electron. It needed 1 more electron, so it valency was 1. In helium it had 2 electrons. It is complete, satisfied. So why will it give or take 1 more electron? Its valency is 0. Okay, understood? Let's see about lithium. Lithium, the number of electron is of the number of electrons is 3. Okay, then the configuration is of 2, then 1. Okay, the first orbit is not complete, the second orbit is now unlocked. 2, 1. Valence electrons 1, because the outermost orbit now has only 1 electron. Then the valency is also 1, because it is now ready to complete its octet as 2. Okay, means it is known as actually a duplet, because 2 is there. So if it is ready to give out this 1 electron in the outermost orbit. Lithium is done. Then comes after lithium is beryllium. Okay, beryllium. What is beryllium? Beryllium number of electrons is 4. Configuration 2, 2. Valence electrons 2. Valence is 2. Alright, understood? Now I am going a little fast because I do hope that you understood it till now. Boron. What is boron? Now let's see the case of boron. Number of electrons 5. Configuration 2, 3. Valence electrons 3. Valence is 3. It is ready to give out 3 electrons to form a duplet. Means the 2 electrons in the first orbit. Then comes carbon. Carbon is of 6 electrons. Total there are 6 electrons. Configuration is 2, 4. valence electron is 4. What is the valency? It is 4. Now 4 electrons it can either give out or it can either take, or means you will understand it in later part, in later sections, that what exactly does carbon do. Okay, it hardly actually does an ionic bond. You will understand it later, but for now remember valency is 4. Nitrogen is of 7 electrons. Configuration is 2, 5. What is the valence electrons? It is 5. What is the valency? It is 3. It is 3 because now nitrogen will want to take electrons. It can give 5 electrons or it can take 3 electrons. It sees that taking 3 electrons is easy because the movement only is 3. So it will now take 3 electrons and hence its valency will be 3. Then comes oxygen. Oxygen is of 8 electrons, 2, 6. Valence electrons is of 6. Valence is 2 now. Okay. Next comes fluorine. Also I am writing it here, neon. Ne means neon. Fluorine. So fluorine, it is of 9 electrons, 2, 7, 7, 1, and neon, it is of 10 electrons. I hope you can see it from here. Yes, okay. 10 electrons, 2, 8, just a minute, 2, 8 valence electrons, and valency is 0. Why? Because its octet is now complete, it is satisfied, it is happy. Okay. So this is how valence and means valence electrons and valency is calculated. Alright, you understood completely. In the next video I will show you how to remember these elements, okay, in order, in proper order. How to remember these elements I will show you in the next video. Okay, so if you feel this video is really helpful, please like it, share it with your friends, and also please subscribe to our channel, because the more you subscribe and share and like, the more it will reach to other students and it will be helpful to them. Okay, so for today, thank you very much.